Neil deGrasse Tyson is one of the most prominent astrophysicists of our time and has offered several insights into the Big Bang and what might have existed before it. The Big Bang is the all-defining event that created the existence of our universe. The question of what came before it is one of the most puzzling and intriguing in cosmology, as it touches upon the limits of human understanding and the nature of time and space itself. Tyson acknowledges that answering the question is challenging due to the nature of the Big Bang, but he's made several key observations that provide context for understanding the broader topic. The Big Bang is a theory that describes the origin of the universe as a point in time approximately 13.8 billion years ago, when all matter, energy, and space expanded from an extremely hot, dense state. This event is often misunderstood as an explosion, but in reality, it was the rapid expansion of space itself. Before the Big Bang, the universe was in a state of singularity, a term used in physics to describe a point where all physical laws break down and all matter and energy are concentrated into an infinitely small point, a point of infinite density and temperature. The Big Bang theory is supported by substantial scientific evidence, such as the cosmic microwave background radiation, a remnant of the early universe that now fills the entire cosmos. Discovered in 1965, this radiation is a key piece of evidence. It is the afterglow of the hot, dense state that the universe was in just 380,000 years after the Big Bang. Another piece of evidence is the observation that galaxies are moving away from each other, which suggests that space itself is expanding. Tyson points out that describing what existed before the Big Bang is tricky because, according to the standard model of cosmology, time began with the Big Bang. He explains that the very concept of before may not apply in the way we typically understand it. Just as asking what is north of the North Pole doesn't make sense because the North Pole is the northernmost point. Asking what came before time began is similarly nonsensical within the framework of our current understanding of physics. Tyson emphasizes that time and space are interconnected, a concept formalized by Albert Einstein's theory of general relativity. In this theory, space and time are part of a single continuum called spacetime. This concept of spacetime suggests that space and time are fundamentally intertwined and cannot exist independently of each other. This fabric of space and time was created during the Big Bang. Therefore, time as we know it did not exist before this event. There can be nothing before the creation of time because time did not exist, nor did space. However, this does not mean that nothing existed before the Big Bang. Tyson points out that there are several theories and hypothetical ideas that attempt to explain what may have been happening before the Big Bang. One of the more popular theories that Tyson points out is the idea of the multiverse. In this framework, the universe we live in is one of countless other universes, each with its own set of physical laws and constants. The multiverse theory suggests that our universe is one of many, with an infinite number that exist in parallel to each other. The Big Bang would not be the beginning of all existence, but rather the beginning of our particular universe only. Other universes could have been expanding, contracting, or existing in completely different forms long before our Big Bang occurred. Tyson refers to this idea when speaking about the limits of our observations. Since we are constrained by the observable universe, we can only make educated guesses as to what might exist beyond it. The multiverse theory suggests that there could be a vast collection of different universes, and some physicists hypothesize that new universes could be popping into existence all the time as part of what is the multiverse. Tyson suggests that while the multiverse theory is captivating, it remains speculative. There is currently no empirical evidence to confirm the existence of other universes, and testing such a theory is incredibly challenging. Nevertheless, it presents a potential solution to the question of what came before the Big Bang, encouraging us to keep an open mind and explore all possibilities. Another hypothesis that Tyson often refers to is quantum fluctuations. This theory comes from quantum mechanics, the branch of physics that describes the behavior of particles at the smallest scales. In the quantum world, vacuum states or empty space are not empty, but filled with fluctuating energy. These fluctuations can give rise to particles that seemingly appear out of nowhere, and some scientists speculate that a similar process might have given rise to the Big Bang. According to this idea, the universe could have existed in this vacuum state before the Big Bang, with quantum fluctuations leading to the rapid expansion of space. Tyson uses this hypothesis to illustrate that the universe might have emerged from nothing, or at least what we perceive as being nothing, through the laws of quantum physics. This concept is difficult to grasp because it challenges our intuitive understanding of nothingness. In quantum physics, even nothing can produce something given the right conditions. Tyson explains that our universe could have been the result of a random quantum event that triggered the Big Bang. He emphasizes the importance of theoretical physics in exploring questions such as what existed before space and time began. He acknowledges that we do not yet have definitive answers, but he remains optimistic about the potential for future discoveries. Advances in fields like string theory and loop quantum gravity may eventually provide deeper insights into the nature of space-time and the origins of the universe, instilling a greater sense of curiosity in the next generation of scientists. Tyson goes on to suggest that while we may never fully comprehend what transpired before the Big Bang, it's crucial to stay open to new ideas and push the boundaries of human knowledge. He emphasizes the value of asking questions, compelling scientists to think beyond conventional frameworks. The mysteries that lie beyond our current understanding of things might remain a puzzle for a long time or even forever. But one day, they could be answered through a breakthrough in physics, inspiring humanity to continue exploring time and the cosmos. Neil deGrasse Tyson's take on what existed before the Big Bang revolves around the idea that time itself started with the Big Bang, making the concept of before difficult to apply. The question of what existed before the Big Bang is one of the greatest puzzles in science, and it may take generations of scientists working together to unravel it. Until then, the cosmos continues to inspire wonder and awe, reminding us of how much we have yet to discover. Thank you for watching, and we will see you in the next episode.